Hi, my name is Nick Sean, and I'm going to be presenting my final project for EE332, which was based on the Smart Eraser prompt. So this prompt challenged us to take this original video seen here on the left with a pen, tracing from right to left across the top of the image, and then in the middle of the image, the words in red, "Can you erase me?" And then the goal here is to make it appear as if as that pen traces across the top of the screen, the corresponding region underneath it with the red text is being removed from the image and erased underneath the pen as it moves. And so the approach here is to first track the location of that pen tip and then use that to determine for each frame what region needs to be erased, and then finally filled in with a texture that resembles the background in the image to make it appear as if only the red text has been removed and everything else is remaining the same. So I'll walk through each part of this step by step. Here, so this first part with tracking the pen approached much the same way as we did the face tracking assignment earlier. And so manually marked the location of that pen tip in the first frame of the image, and then for each successive frame after that, use a local exhaustive search around the previous known location, find the closest match to that pen tip based on a normalized cross correlation. And so you can see there on the right, the result doing that iterating across the video tracks the pen across the screen just fine. So we can move on to the next step. Then determining what region in each frame needs to be erased and then replaced with an appropriate texture infill. And so for this, I manually predetermined what the Y region should be to make sure that all of the red text was captured within it. And then the X range for that rectangle of the erased space is determined based on the current position of the left edge of the pen bounding box, and then from there to the right edge of that pen tip bounding box in the original or the initial frame of the video. And so you can see here what that looks like as it traces across. Now with the pen tip, you're seeing the rectangular region to be erased forming underneath of it. So now we get to the really interesting part of this project, and figuring out a good way to appropriately fill in that blank space so that it appears to be the same texture that was present initially and blends in well with the surrounding textures. So the first step to doing this is to randomly sample several different N by N templates, patches of texture from the surrounding area in the image to use as sample patches, and then those can then be stitch quilted together to create a nice looking fill that seems consistent with the original image background. And so then to make sure that as each patch is filled in, that it fits well with the surroundings, because we're dealing with not just generating a texture de novo, but we're actually trying to fill it in so that it fits with that surrounding original image. For each one, you need to make sure that the patch being selected fits in well, reasonably well with the surrounding image boundaries. And then as a final step, image blending was used here to make a nice clean transition between images by considering an overlap region and not requiring straight lines. And I'll describe the method in a little bit more detail on the following slide. So that first part of picking the right template, the approach I used here was out of the pool of many potential template patches that could be placed at a given location in the fill. You want to select one that minimizes the total sum of square differences with the overlapping region, with the overlap with any pre-existing regions in the surroundings. Could be the original image, or could be other patches that have already been placed by that point. And so then up to 4 potential boundary areas, right, left, top, and bottom, need to be considered based on the pre-existing surroundings of the fill. And then if you pick a patch that appropriately minimizes the sum of square differences, then you have one that would tend to blend in well with the pre-existing boundary, so that you don't have these kind of sharp, obvious borders in between each patch. So the next step to even further smooth those transitions between patches and between the fill and the surroundings, and then use image blending here. So then for each case where a patch is being placed, at each boundary, it will have a certain amount of overlap. So here in this example, there's 10 pixels of overlap, and then originally 2 30 by 30 pixel regions that are trying to be stitched together here. And so this kind of jagged boundary that's formed here is determined by finding a path that minimizes the total cost in terms of sum of squared differences between the two patches being stitched together. Finds a path from top to bottom that then minimizes the sum of squared differences along that path. So finds a region where the images are a path where the images are reasonably similar, and uses that as a boundary so that there's a more smooth transition between each of the two patches. And so this again also needs to be considered for each side where there's any overlap with pre-existing image. And so in my code, it considers the sides in sequence and uses that then to make a composite kind of stitching of how that new patch will fit in with the existing fill and image. And so putting this all together, basically the code will iterate across the requested fill space, placing patches starting from the top right, and then moving along the image as it goes, and filling in patches. And every time it places a patch, is the image blending, and then continues until it's filled in the entire region. And so for simplicity, in terms of computation, and also to ensure that in each frame of the final video, that the fill always stays consistent in regions that have already been filled, I compute the fill only once on the entire maximum region that needs to be filled in, which is based on the last frame of the video. So you can see here the original final frame, and then the filled in frame where it has filled the entire erased region using the method with the texture infill that I just described. And so here's the final result that you get after going through all of these steps. And so taking that that full fill, and then in each frame now, it only replaces the erased region with the relevant portion of the fill, and then does that for each frame throughout the entire video, and you get this nice clean looking erasure where you got this texture that generally blends in fairly well with the surrounding images. And so some of the parameters that I had to kind of tinker with a little bit to get this result was for the patch size. I found 30 by 30 pixels worked well. The overlap between patches, which again I found 10 worked fairly well here. And then also found that the number of randomly sampled patches that you pull from can be good to make sure that it's sufficiently large so that there are so that you end up with a good variety of patches, and you end up with patches that fit well in most of the places where you need to place them. And so I found 100 generally worked pretty well in this particular circumstance. And it was also important here when randomly sampling those patches to ignore these boundary regions. So it didn't consider any patches that included these kind of blank spaces around the side or this different coloration down at the bottom, because those will then lead to some kind of odd results because they don't really fit in with the majority texture that's through most of the center of the image. So finally, wrapping up, describe some of the ways that I see this project could move further. Mostly revolves around automating the procedure a little bit more, generalizing it so that it can work on other videos by automatically identifying the pen tip and the region to be erased, allowing for multiple different directions of erasing depending on the way that the video works, and then most interestingly, optimizing the overlap and the template size selection and picking that automatically could perhaps be done based on the spatial frequencies present in the image, which I think would be an interesting approach to kind of explore. And so in conclusion, this was a really interesting project and really enjoyed the course this quarter, and I hope Hope this has been a useful and informative presentation for everyone else. Thanks.